Today we will learn about projection of lines, that is how to draw the plan and elevation of lines on reference planes when they lie in different quadrants. We will also learn about how to find the true length of the line, how to find the true inclination of these lines with respect to the reference planes, and also how to locate the traces of the line. So before starting, let us see what is meant by a straight line. A line joining two points along the shortest route is known as the straight line. The two ends of a straight line can also be considered as points. If we can obtain the projection of 2 points which forms the two ends of a straight line, it is possible to get the projection of the straight line. For example, if we know the top views of the starting and end points of a straight line, then the line connecting top views of those 2 points will give the top view of the straight line. Similarly, if we know the front view of starting and end points of a straight line, then the line connecting the front view of these 2 points will give the front view of the straight line. Now, we know that a straight line can occupy an infinite number of positions in space with respect to the reference planes. We can classify the various positions into 4 different cases. The first one, the line parallel to both the reference planes. That is the line which is parallel to both horizontal plane as well as the vertical plane. The second case is the line will be parallel to any one of the plane, either HP or VP, and it will be perpendicular to the other one. Now the third case is the line which is parallel to any one of the plane and it will be inclined to the other plane. And the last case is the line which is inclined to both the planes. So in this video, we will solve examples for the first 3 cases, and the examples for the last case, that is when the line is inclined to both the planes, will be continued in the next video. Now we will see how to get the projection of the lines for these 4 different positions. Now let us take the first case, that is the line which is parallel to both the planes. So in the figure you can see that we have 2 planes, one is the horizontal plane and the other one is the vertical plane. So these 2 are our reference planes. Now I am considering a line capital AB which is kept parallel to the horizontal plane as well as parallel to the vertical plane. Okay, and the distance of the line AB from the vertical plane is marked as small d, and distance of line from the horizontal plane, it is marked as small h. Okay, now the important point is the line is parallel to the horizontal plane as well as parallel to the vertical plane. Now when we look this line from the front, we'll get the image of the starting point as well as the ending point of this line on the vertical plane. So these 2 lines shows the projectors of A and B. What are projectors? Projectors are imaginary lines, right? Connecting the original point and the projected point. Okay, so these 2 are the projectors of capital A and capital B when you look from the front. So we will get 2 points on the vertical plane. Let that be A dash and B dash. These 2 points are known as the elevation of capital A and capital B. Now if we know A dash and B dash, you can connect these 2 points which will give the projection or the front view of the line capital AB. So we'll get the front view, which is also known as the elevation of the line capital AB on the vertical plane. And I have marked that line as A dash B dash. Now what is A dash B dash? A dash B dash represents the elevation or front view of capital AB. Clear? Now when you look from the top, you will get the image of this line on the horizontal plane, right? So I will get the projection of capital A somewhere here and projection of capital B somewhere here, and these 2 lines are known as the projectors of A and B. So I will get 2 points on the horizontal plane, let it be small a and small b. Now if you connect these 2 points with the help of a line, that line is known as the plan or top view of the line capital AB. Clear? So this AB denotes the plan or top view of the line capital AB. Okay. Now, when you look from the front, you'll get the image of this projectors on the vertical plane, right? See, these two are the images of these two projectors. So, what will be the length of this projectors? That will be the height of capital A and B from the horizontal plane, right? That is this length. The distance of elevation from the XY line will be equal to the distance of capital A or capital B from the horizontal plane. So, the distance from the horizontal plane will be marked on the vertical plane. I hope that is clear. The distance from the horizontal plane will be marked on the vertical plane. Similarly, when you look from the top, you will get the image of these two projectors on the plan. Now, what is this length or what is this length? Distance of A and B from the XY line. This distance will be the distance of capital A and capital B from the vertical plane. So, the distance from the vertical plane will be obtained on the horizontal plane, and the distance from the horizontal plane will be marked on the elevation. Okay. Now, the most important point is, see, if the line is parallel to any of the plane, you will get true length on that plane, right? So, here you can see that the line capital AB is parallel to VP. What does that mean? The image of the line obtained on the vertical plane will be true length. So, the length of A dash B dash will be equal to the length of AB. So, that is very important point. This has to be remembered. If the line is parallel to any one of the plane, you will get true length on that plane. If the line is parallel to vertical plane, you will get true length on vertical plane. If the line is parallel to horizontal plane, you will get true length on horizontal plane. Here you can see that the line AB is parallel to horizontal plane also, right? So, the length AB will be equal to the length of capital AB. So, in our case, elevation as well as plan will be true length. That is very important. Now, the second point is, see, if the line capital AB is parallel to vertical plane, you will get a horizontal line on HP. That is the second very important point. Okay, if the line is parallel to VP, the image of the line on the horizontal plane will be horizontal or will be parallel to XY. Clear? If the line is parallel to VP, you will get horizontal line or the line parallel to XY on the horizontal plane. Similarly, if the line is parallel to HP, you will get the elevation as a horizontal line or the elevation will be parallel to XY. Hope that is clear. Okay, that is the second important point. If the line is parallel to VP, we will get horizontal line on HP. If the line is parallel to HP, we will get horizontal line on VP. Clear? Now, the third important point is the distance of the elevation points. The distance of the elevation points from the XY line will be equal to the distance of the original points from the horizontal plane. Clear? So, the distance of the elevation points will be equal to distance from the horizontal plane. Similarly, the distance of the plan points, that is the distance of small a and distance of small b from the XY line, will be equal to the distance from the vertical plane. Okay, so these are the three important points to be kept in mind. Now we will try to draw the orthographic view, which is very important as far as university exams are concerned. Okay, so for that, first we will draw the reference line XY. Okay, so this represents the reference line. Now, we know the distance of elevation points from the XY line. What is that distance? That distance will be the distance from the horizontal plane, right? Distance of the original points from the horizontal plane, that is small h. So, first I will draw the projector of A dash. Then I will draw the projector of B dash. What is the distance between these two projectors? As I have told earlier, since the line is parallel to VP, we will get true length on VP. So, the distance A dash B dash will be equal to the original length of the line. So, you can mark the original length here So that will be the distance between these two projectors. What about the height of A dash and B dash? That also will be same, right? Because the line is parallel to HP. Since the line is parallel to HP, the distance of A dash and B dash will be same. So that will be equal to H. So you can mark H distance here. You will get the first point A dash. Here also you can measure the distance H. You will get the second point B dash. The distance between these two projectors will be the length of the original line itself. So this represents, this line A dash B dash represents the front view or the elevation of the line. Now I will try to draw the plan of the original line. So in order to draw the plan, we need this distance, right? What is this distance? This distance is distance from the vertical plane, right? Now since the line is parallel to VP, this distance and this distance, that is distance of A from XY and distance of B from XY will be same, and that will be equal to D, right? So I will draw this. Yes, I have drawn the projectors. So A will be exactly below the point A dash and B will be exactly below the point B dash. Okay, so you can mark A and B. What about this length? This length also will be true length. Why? Because the line is parallel to HP. Since the line is parallel to HP, the plan will be true length. Since the line is parallel to VP, the elevation will be true length. Now what is this distance? That is the distance of the original points from the vertical plane. So this represents the orthographic view of this line. Okay, now this line denotes the reference line. The top line, this represents the front view or elevation of the line, and this one represents the top view or plan of the line. So length of line on elevation and plan will be equal to true length if the line is parallel to both the planes. Now let's see some of the important points which is to be kept in mind. So if the line is parallel to HP, we will get true length on HP, right? On HP, we will be getting the plan, right? On HP, we will get the plan. So the plan will be true length. So the distance AB will be equal to true length. Now, the elevation, that means this one, the elevation will be parallel to XY. So if the line is parallel to HP, the elevation will be parallel to XY. Clear? So the distance of A dash will be equal to distance of B dash, which will be equal to distance of the original points from the horizontal plane. So these are the points to be kept in mind when the line AB is parallel to HP. Now, if the line is parallel to VP, you will get true length on VP, and on VP we will be getting the elevation, right? So the elevation will be true length. So the length A dash B dash will be equal to true length of the line. Now, if the line is parallel to VP, the plan will be parallel to XY. Clear? The plan will be parallel to XY. And the distance of A and B will be same, and which will be equal to distance from the vertical plane. So these are the points to be kept in mind. Clear? Now we will solve two problems on the first case. So example 1. A straight line capital AB of length 70 mm is parallel to both HP and VP. The point A is 20 mm above HP and point B is 35 mm in front of VP. Draw its projections. So here the original line is given as capital AB and the length of that line is given as 70 mm. It is also said that the line is parallel to both HP and VP. So if the line is parallel to both HP and VP, we know that the true length will be obtained on VP as well as HP, right? Since the line is parallel to horizontal plane, we will get true length on HP. Since the line is parallel to VP, we will get true length on VP also. Now, the second point is, since the line is parallel to HP, we will get horizontal line on VP, or the elevation will be horizontal. And since the line is parallel to VP, we will get horizontal line on top view or plan. Okay, so in order to draw the orthographic projection of this line, we need the distance of any one of the elevation points as well as distance of any one of the plan point from the XY line. So that is also given here. See, the point A is 20 mm above HP. That means the distance of A dash above the XY is given as 20 mm, right? So we got distance of A dash So you can mark the distance of B dash also, since A dash B dash will be horizontal, right? Similarly, the second point is also given. Point B is 35 mm in front of VP. That means the plan point, right? The plan point is given as 35 mm below XY line. So we know distance of small b from the XY line. So distance of small a from the XY line also will be equal to 35 mm, since the line is parallel to HP and VP, right? So these are the important points. Parallel to both the planes, therefore elevation and plan will be parallel to XY and will be horizontal. The second point is the projection of line on VP and HP will be true length, right? Since the line is parallel to HP and VP, you get true length on both the planes, right? So how will you draw the orthographic view? So first we will draw the XY line. Then we need to mark the distance of elevation from the XY line. So that is given, right? The point A. That means A dash is at a distance of 20 mm above the XY line. So B dash also will be 20 mm above the XY line. And the distance between these two projectors will be true length of the line, right? So 70 mm. So you got the elevation A dash B dash. Similarly, A and B will be exactly below the point A dash and B dash. So you can draw the projectors of A and B, which will be at a distance of 35 mm below the XY line. So you can join A and B, that will give the plan AB, whose length also will be equal to the original length, that is 70 mm. Clear? Okay. Now let us take the second question. So here you can see that the line capital PQ is in HP. That means the line is lying on the horizontal plane and it is parallel to VP. Now, if the length of the line, that is true length is given, right? Original length of the line is 65 mm and the point Q is 30 mm in front of VP. Draw its projection. So, see here, you can see that the line PQ is lying on the horizontal plane and it is parallel to the vertical plane, right? So, since the line lies on the horizontal plane, when you look from the front, the elevation of P and Q will be obtained on XY line, right? That we have already learned in the projection of points, right? So the elevation will be obtained on XY line. So P dash, Q dash will be obtained on XY line. Now since the line PQ is parallel to VP, the elevation will be true length. So you know the distance between the 2 points also, which will be equal to 65 mm. Now when you look from the top, since the line lies on the horizontal plane, that is actually parallel to the horizontal plane, right? So since it lies on the horizontal plane, the plan points also will be same as the original point. So you will get small p and small q here, which will be parallel to XY line, right, at a distance of 30 mm in front of VP. So how will you draw the orthographic view? So these are the important points. Yes. Yeah. First draw the XY line. Then P dash and Q dash will be obtained on the XY line, right? Since the line lies on HP. So P dash, Q dash, what is the distance between P dash and Q dash? That will be true length, that is 65 mm. Then since the point Q is 30 mm in front of VP, you can mark the plan point, right? It will be below the XY line. So since the line is parallel to VP, you will get horizontal line on HP, that is plan will be horizontal. So you know the distance of P also. It also will be 30 mm below the XY line. Now join these 2 points, that will give the plan of the line capital PQ. Clear? Okay. Now let us take the second case, that is the line which is parallel to any one of the plane and perpendicular to other plane. So here I am going to consider a line capital AB which is kept perpendicular to the horizontal plane. At the same time, it is parallel to vertical plane. So here LEN denotes the length of the line and the point B, original point B, is at a height of small h above the horizontal plane. Now the distance of the line from the vertical plane is given as small b. Okay. Now when you look from the front, since the line is parallel to VP, you will get true length on VP, right? You will get true length on VP. So these 2 lines shows the projectors. You will get 2 points on the vertical plane, that will be A dash and B dash. You can join these 2 points, that will give the elevation or front view of the line capital AB, which will be true length, right? So this length will be equal to LEN itself. Now what will be the distance of B dash? That will be equal to the distance of original point above the HP. So this distance will be H itself, right? Okay. Now when you look from the top, since the line is kept perpendicular to HP, you will get a point on the horizontal plane, right? You will get only a point on the horizontal plane, and also you can see that A is the visible point here. When you look from the top, this point is visible, but what about B? B comes exactly below the point A, so B will be invisible. So how will you mark the point? So this is our plan point, and you can mark the point like this: A comma B inside the bracket. Why you are putting a bracket for B? Because B is invisible. B lies exactly below the point A. So when you look from the top, you will be able to see only the top point. So that is A comma B. So this represents the plan, and this represents the elevation, right? So the elevation will be true length, and in plan you will get a point. Now how will you draw the orthographic view? So first we can draw the XY reference line XY. Then I have drawn the projector. So here you can see B dash is at a distance of H above the horizontal plane. So you can mark B dash here, right? So you can mark B dash, which is at a distance of H. Now the true length will be obtained on the vertical plane. It will be vertical, right? Here you can see that, right? So A dash will be at a distance of LEN from B dash. So you got the elevation, and on plan you will get a point, right? So which will be at a distance of small d from the vertical plane. See this distance, that will be equal to the distance from the vertical plane. So this gives the orthographic view for this particular case. Now what are the important points to be remembered? If the line is parallel to VP, you will get true length on VP. Elevation will be obtained on the vertical plane, right, on VP. So elevation will be true length. That is, the length A dash B dash will be equal to true length. Now the distance of A dash and B dash will be the distance of the point from the HP. That will be obtained on the vertical plane. Now if the line is kept perpendicular to HP, see the plan will be a point. That you can see from the figure itself, right? The plan will be a point. So A and B will be the same point. That also you can see here. A and B both are same, but we will put B inside the bracket since it is invisible, right? So the distance of A and B will be equal to the distance from the vertical plane. So these are the points to be kept in mind. Now we will solve two problems. So line CD, which is 40 mm long, is in the first part. The NC is 10 mm above HP and 20 mm away from VP. If the line is perpendicular to HP, draw its projection. So here you can see that the line lies in the first quadrant, right? So both the elevation will be obtained above the XY line and plan will be obtained below the XY line. We have learned in the projection of points, if the point lies in the first quadrant, you will get elevation above the XY line and plan below the XY line. So here end C of the line is 10 mm above HP. That means C dash is given as 10 mm above the XY line and it is 20 mm away from VP. So it will be at a distance of 20 mm below the XY line. Now if the line is perpendicular to HP, you will get a point on the HP, right? That means plan will be a point. You can mark that point, which will be at a distance of 20 mm from the XY line. Now what about the elevation? When you keep the line perpendicular to HP, it will be parallel to the vertical plane. So you will get true length on vertical plane, right? So here you can see that the line is kept perpendicular to HP. C is at a distance of 10 mm above the HP. The length of the line is given. So you will get true length on VP, that is 40 mm. And this distance from the vertical plane is at a distance of 20 mm. Okay. First draw the XY line, reference line. Then draw the projector. Then mark C dash, which is at a distance of 10 mm, right? So from here you will get a true line. So D dash will be at a distance of 40 mm from the C dash. Now the plan will be a point. So when you look from the top, you can see this point B. C will be exactly below the point D. So you have to put C inside the bracket. So this is the orthographic view for the given question. Clear? Now let us take another example. A 35 mm long line RS is positioned in such a way that it is perpendicular to VP. So the line is kept perpendicular to VP. So you will get a point on the vertical plane. That means elevation will be obtained on the vertical plane and the line will be parallel to the horizontal plane. So you will get true length on horizontal plane. And the end R of the line is touching at a height of 25 mm from the XY line. The end R of the line is touching. So the line is kept perpendicular to the vertical plane and one end of that line is touching the vertical plane, right? And it is touching at a height of 25 mm from the XY line. See, this is the case. So RS is the line. It is kept perpendicular to vertical plane, right? And one end of the line is touching the vertical plane. Okay. Now, since this line is parallel to HP, when you look from the top, you will get true length on HP. So the plan will be a vertical line, right? The plan of this one will be a vertical line whose length will be equal to 35 mm. So where will you get the starting point R? When you look from the top, this point appears to lie on the XY line. So small r will be obtained on the XY line. From here you will get a straight line, right? S will be obtained somewhere here, which is at a distance of 35 mm. So you will get a vertical line on the plan, and on the elevation, that is when you look from the front, you will get a point here which is at a distance of this much, right, from the horizontal plane. What is that distance? Above the XY line, it is 25 mm. So the point will be obtained 25 mm from the XY line. So how will you draw the orthographic view? First draw the reference line, then mark R on the XY line, right? Then S will be below the XY line at a distance of 35 mm, right? Then you will get a point above the XY line, that will be S dash and R dash. When you look from the front, S is visible, R will be invisible. So you are putting R dash inside the bracket. Clear? Okay. Now let us take the third case, that is the line parallel to any one of the plane and inclined to the other plane. So here I am consider a line capital AB which is parallel to VP and inclined to HP. Now since the line is parallel to VP, you will get the true length on VP and the plan will be a horizontal line since the line is parallel to, right? That we have already learned. If the line is parallel to VP, we will get true length on vertical plane. Again, the second point is if the line is parallel to VP, the plan will be a horizontal one. Okay. Now, when we look this line from the front, we will get A dash and B dash on VP, right? And when we join this A dash and B dash, we will get the front view or elevation of the line capital AB. And this A dash B dash will be true length, whose length will be same as the length of the original line. Now when you look from the top, you will get A and B on the horizontal plane. So when you join these 2 points, you will get the plan or top view of the original line capital AB, which will be a horizontal one, right? Okay. Now we will try to draw the projection of this original line in the orthographic view. So first we will draw the reference line XY. Then we will mark A dash. What is A dash? A dash is the distance of elevation above the HP, which is given as HA. And the distance of B dash is given as HB. Okay, so you can mark HA. Then the distance of A will be equal to distance from the vertical plane, right? Distance of B also will be same as the distance of A. Okay, so you can mark small a. Then you can mark B dash, and this distance A dash B dash will be equal to true length since the line is parallel to VP. Okay, now B also will be at a distance of small d from the XY line. So AB denotes the plan or top view of the line. So this one will be a reduced one. Since the line is parallel to VP, you will get horizontal line on plan. And since the line is parallel to VP, you will get true length on elevation. Clear? Okay, now let's see what are the important points. So if the line AB is parallel to VP, we will get true length on VP. That means the elevation which is obtained on the vertical plane will be having true length, right? So A dash B dash will be true length. Now the distance of A dash and B dash from the XY line will be equal to the distance of the original points from the horizontal plane. Now since the line is parallel to VP, the plan will be parallel to XY line, right? So AB will be a horizontal line, and that means the distance A will be equal to distance B, which will be equal to the distance of the original point from the vertical plane. Now since the line capital AB is inclined to HP, we will get a reduced line on the horizontal plane. Please note this one. If the line is inclined to any of the plane, you will be getting a reduced length on that plane. That means if the line is inclined to HP, you will get a reduced line on HP. If the line is inclined to VP, you will get reduced line on VP. So please keep that in mind. Now in our case, since the line capital AB is inclined to HP, the plan will be a reduced line. Okay, now let us assume that the original line capital AB makes an angle of theta with the horizontal plane. Now since the line is parallel to VP, we will get true length on VP, and the inclination made by the elevation with the XY line will be equal to this theta. Clear? Or in other words, the angle made by the original line with the horizontal plane will be obtained on the elevation. So the angle made by the elevation with the XY line will be equal to the angle made by the original line with the horizontal plane. And this is true only if the elevation A dash B dash is true length. Clear? Okay. Now, if the line is inclined to VP, then that angle will be obtained on the plan, right? So the angle made by the plan AB will be equal to the angle made by the original line with the vertical plane. Now, if the plan length is equal to the length of the original line, then this inclination, which is obtained on the horizontal plane, will be true inclination or true angle. Clear? So here in our case, the angle made by capital AB will be obtained on the vertical plane, and since A dash B dash is equal to true length, this angle which is obtained on the vertical plane will be equal to the true angle which is made by capital AB with the horizontal plane. Clear? Okay. Now let us solve 2 or 3 questions in this case also. A line capital EF 60 mm long is parallel to VP and inclined 30 degrees to HP. The end capital E is 10 mm above HP and 20 mm in front of VP. Draw the projections of the line. So here the original line of length 60 mm is given, and it is told that the line is parallel to VP. So if the line is parallel to VP, we will get true length on VP, and the plan will be a horizontal line or a line parallel to XY. Right? Okay. Now this line is inclined 30 degrees to HP. So the original line makes an angle of 30 degrees with HP. So here we know that the elevation, since the line is parallel to VP, the elevation also will make 30 degrees with XY line. Right? So elevation will also make an angle of 30 degrees with the XY line. Clear? Now we will try to draw the orthographic projection of this line. So first we will draw the XY line. Then here we know the end E is 10 mm above HP. That means E dash is 10 mm above XY and 20 mm in front of VP. So E will be 20 mm below the XY line. Right? So we got the points E dash and E. Now since the line makes an angle of 30 degrees to HP, the elevation will make an angle of 30 degrees with XY line, right? So you can draw this line. Now since the line EF is parallel to VP, you will get true length here, right? So E dash F dash will be true length. So once you got this point F dash, you can draw the projector of F, right? And on that projector you can mark F, whose length will be equal to 30 mm from the XY line. Why? Because the line is parallel to VP. So the plan will be a horizontal line. Since we know the distance of E from the XY line as 30, the distance of F also will be 30. So joining these 2 points, we will get the plan EF. Okay, this gives the orthographic projection of the given line. Okay. Okay. Now the next question, the length of elevation of a line GH. The length of elevation of the line is given. Elevation means front view. The length of the front view, that means G dash H dash is given, right, which is parallel to HP. The line is parallel to HP. If the line is parallel to HP, we have 2 points. One is we will get true length on HP. That means the plan will be true length, and the elevation which is obtained on the vertical plane will be a horizontal one. Okay, so G dash H dash will be a horizontal line. Clear? And the line is inclined 30 degrees to VP. The line is inclined 30 degrees to VP. So if the line makes an angle of 30 degrees with VP, that angle will be obtained on the plan. When you look from the top, you will get that angle, right? So on plan, that means small g, small h. That line will make an angle of 30 degrees. Now, since the line is parallel to HP, small g, small h, that plan length will be true length. Since that length is equal to the original length, the angle made by GH with the XY line will be true angle, and that will be equal to 30 degree, right? Okay. Now let's see the important points here. The line is given as parallel to HP. That means we will get true length on HP, or the plan will be true length. Plan small GH will be true length. Then the second one is the elevation will be a horizontal line, right? Since the line is parallel to HP, the elevation obtained on VP will be a horizontal, and the length of that horizontal line is given here, right? Length of the elevation, length of the front view is given as 50 mm. So G dash H dash is equal to 50 mm. Clear? Now the NG starting point of the line is 15 mm in front of VP. That means G is given, right? G is given as 15 mm below the XY line and 25 mm above the XY line, right? Then the plan makes an angle of 30 degrees with VP. Clear? So it makes an angle of 30 degrees with XY. Now since G dash H dash is horizontal, H dash also will be 25 mm. So we will draw the orthographic projection. First we will draw the projector of G. So you can mark G dash, which will be equal to 25 mm, and you can mark G also, which will be equal to 15 mm. Right? Now G dash H dash is horizontal, and the length is given as 50 mm. So you can mark H dash. So once you mark H dash, you can draw the projector of H dash, right? Okay, you can draw the projector. This shows the projector. Now we don't know the point H, right? So for that, we know that the line GH, if you are drawing a line here, the plan, it makes an angle of 30 degrees with XY, right? So you can mark 30 degrees and draw a line which meets the projector through H dash, right? So that point will be small h. So this gives the plan, and this one is the elevation. So you can mark all the dimensions here. This is 50 mm, this is 25 mm, this is 15. When you measure the true length, you will get that distance as 58 mm. Okay, and this angle, since the line GH is equal to the original length, the angle made by that length with the horizontal will be the true angle. So this will be the angle made by the original line with VP. Clear? Now let's take the next question. A line capital PQ 70 mm long is parallel to HP. So here the line is parallel to HP, so we'll get true length on HP. Plan will be true length, right? And the elevation will be a horizontal line. Now its end P, the starting point of the line P, is 20 mm in front of VP. So small p is 20 mm below XY line, and Q is 25 mm behind VP, right? That means the small q is given 25 mm behind VP. Behind VP means it will be above the XY line, right? So the plan, since the line is parallel to HP, the plan will be true length. Clear? So the distance PQ will be equal to 70 mm. And the elevation, that is P dash Q dash, that will be a horizontal line. Okay, now if the line is 35 mm above HP, that means the elevation point, right? The line is 35 mm above HP, that means the distance of elevation from the XY line, that is given as 35 mm. So since P is If P is equal to 35 mm, Q also will be 35 mm. Now, draw the projections of the line and find the inclinations to VP. So, these are the important points. The line is given as parallel to HP. So, plan will be true length and elevation will be a horizontal line. The true length will be obtained on plan, right? And the length PQ is given as 70 mm. Then plan point P is 20 mm below XY. Plan point Q is 25 mm above XY. P dash and Q dash will be equal to 35 mm since the line is horizontal, right? Okay, so we will mark all these points here. First, we will draw the projector of P. So you can mark 20 and 35 there. 20 plan point and 35 elevation point. Then we don't know the distance between the projectors of P and Q, or in other words, we don't know where to draw the projector of Q. So we will draw the locus of Q here. We will draw a horizontal line which denotes the locus of Q. That means the Q can be anywhere on this line. Q means the plan point. Plan point is 25 mm above XY. So you can mark 25 mm here. You draw a horizontal line which represents the locus of Q. So Q can be anywhere on this line. And we know that the distance PQ is true length, right? PQ is 70 mm. Now you take 70 mm in the compass. You place the needle at P and mark 70 mm on the locus, which will give the point Q, right? So this line denotes the plan. Okay, this line denotes the plan. When you try to measure the angle of this line, it will be equal to 40 degrees. Okay, so since PQ is equal to the original length, the angle made by this P with the XY line gives the angle made by the original line with the vertical plane. Okay, let it be there. Now, how will you mark Q dash? Now you can draw the projector through Q, right? So you can draw the projector, and Q dash also will be equal to 35 mm. So you can mark Q dash, and this gives the elevation of the line, which will be equal to 50. Now, before moving on to the fourth case, let us see what is meant by trace of a line. So the point of intersection of a line with a plane, that is known as the trace. If the line is inclined to any of the planes, then we will have a trace for that line. So if the line is inclined with the horizontal plane, we can see that the line, when extended, will meet the horizontal plane at a point, and that point is known as the trace of that line. So if the line meets the horizontal plane, the point of intersection will be known as the horizontal trace, and if the line is inclined to vertical plane, we can see that when the line is extended, it will meet the vertical plane at a point, which will be known as the vertical trace of that line. In the figure, you can see that the original line AB is inclined to HP. So when you extend the original line AB, you can see that the line meets the horizontal plane at a point which is known as the horizontal trace, and that is denoted by capital HT. Now when you look from the front, you will get the elevation of this trace, which will be obtained on the XY line. Okay, and that is denoted by HT dash. Similarly, when you look from the top, plan of the trace will be obtained at this point itself. Okay, so that will be denoted by small ht. Okay, now here you can see that when you extend the line A dash B dash, that is meeting the point ht dash. Right. Similarly, line of intersection of the plan as well as the projector through ht dash will meet at the horizontal trace or small ht. Now let's see how to locate the ht dash and ht on the orthographic projection. So in order to get the horizontal trace, we need to extend the elevation first. So you extend A dash B dash, so that will meet the xy line at ht dash, right? Then you drop a perpendicular through ht dash, okay, and extend the line small ab. So these two lines will meet at a point which represents the original horizontal trace or the plan of the horizontal trace. Now let us consider another case. So here you can see that the line is inclined to vertical plane. So when you extend the line AB, that will meet the vertical plane at a point, and that point will be known as the vertical trace of the line capital AB. Now in order to get the plan and elevation, we will observe this vertical trace from the front and from the top. So when you observe the point from the front, you can see that the elevation of that point will be obtained on the vertical plane itself, right? And when you look from the top, the point appears to lie on the xy line. So that will be denoted by small vt. Now, how will you obtain the vertical traces in orthographic projection? For that, you need to extend the line AB, and that will meet the xy line at small vt. Then you drop a perpendicular through the vertical trace, extend the elevation A dash B dash, and these two lines will meet at a new point, which is denoted by the original vertical trace or elevation of the vertical trace. Now, let's move on to the fourth case, that is the line inclined to both the planes. So, in this case, when we try to project the original line on the vertical plane as well as on the horizontal plane, the length of the elevation as well as the length of the plan which is obtained will not be giving true length. Why? Because the line is inclined to both the planes. So, both the elevation as well as the plan will be having a length which is less than the original line. Similarly, the angle made by the elevation with the xy line as well as the angle made by the plan AB with the xy line will not be true angles, since the elevation as well as the plan are not true length. So here we need to find out the true length of the line as well as the true angle of inclination with the planes. So these are some of the points to be remembered. If the line is inclined to both VP and HP, we will get reduced length on VP and HP since the line is inclined to both the planes. That means the elevation and plan will be having a length which is less than the original length. Now, both plan and elevation will be inclined to XY, and the angle of inclination obtained on HP and VP will not be true angles. Now, the distance of A and B will be equal to distance from VP, and distance of A dash and B dash will be equal to distance of the original point from the horizontal plane. So, we will wind up today's session, and the problems related to the fourth case will be continued in the next video.